Alright, let's recap. So we learned how to collect data and communicate it using the NRF radios. We then visualized the data on our LCD screen. And then we learned about Wi-Fi through Explora 8266 module, which we used specifically ESP01. And then we learned about ThingSpeak, the cloud. And the reason why we learned about Wi-Fi is because we needed access to the internet. And the reason we learned about ThingSpeak is because we needed a place on the internet, on the cloud, to store our data once it was collected. Today we're going to introduce the last topic for this project, which is WDT, which stands for Watchdog. And the reason you use Watchdog, and a lot of standalone electronics use it, is mainly two reasons. Number one, power savings, and we'll get into that. And number two, because it is a way to reset or reboot your microcontroller in case it runs into issues that might hang it up and basically render your project useless. So you want to be able for it to reset itself without you having to intervene. So let's go ahead and take a look at Watchdog. Okay, so we had this setup where a warehouse needs to be monitored. Its data needs to be communicated via an RF radio frequency communication to a office building, and this office building has Wi-Fi access to the internet or the cloud, which it will use to post the data to ThingSpeak, which is basically our data storage online. Let's take a look at where Watchdog comes in. So AVR is a library or set of libraries that helps us do something which is important, which is sleep. We want to be able to post data to the internet, but incredibly enough, we want the MCU to have the ability to sleep. So it might sound like a complicated concept, but it really isn't. Think about your CPU or your MCU as doing its tasks. And the way it does that is because it has a clock, and it knows at what times to perform certain tasks. That's simple enough, right? Well, there's somebody else in there with your MCU, and he's called a watchdog. And what he does is he runs by himself, and the most important thing is that he's got his own clock. So the way it works is the CPU can activate this watchdog, which is kind of like a timer alarm. And the watchdog, once activated or enabled, will be able to do stuff back to the CPU, depending on what you tell it to do to the CPU, such as waking it up or resetting it. And basically the CPU can enable the watchdog and tell him, okay, just hang low and don't do anything unless I don't pat you on the head. And if the CPU pats the watchdog on the head every so often, then the watchdog is said to not bite back. So it won't bite the CPU back by resetting it or by waking it up. It'll just sit there with its own clock, not doing anything, so long as the CPU, or the MCU in our case, pats him on the head every so often. That's its timer. Now, if the CPU doesn't pat the dog, then the dog is going to bite back. And there's basically two ways of biting back. One of them is that it'll send a small pulse of electricity to wake up the MCU, because maybe the MCU went to sleep to save power, which is what we're going to use it for first. Or it might send a command to actually reboot the CPU, which means basically the CPU is telling the watchdog, hey, you know what? If it's been an hour and I haven't patted you on the head, that means I'm stuck. So go ahead and reset me. So that's the second reason why we use Watchdog. So let's go ahead and see how this works. Okay, so how does this Watchdog reset works? Here's a very simple code which starts out in the setup by turning the LED on and then turning it off, and essentially making it blink once. Then it goes to the loop and it does this thing called WDT enable, which means it enables the watchdog. And it did so for 15 milliseconds. What that means is that it will count 15 milliseconds and it'll turn around and bite the MCU, or basically reset it. Okay, so let's go ahead and actually take a look at what this looks like on our Uno. Now remember, the blink code is in the setup function, which means that it should only blink once, not more than that. But the loop is telling it that the watchdog is enabled and it should bite every 15 milliseconds. So let's go ahead and get this serial monitor out of the way and take a look at what happens. Here's our MCU, and as you can see, it is blinking constantly, repeatedly. This is because every 15 milliseconds, which is what we have enabled the watchdog to do, is biting back because we're not padding it. So we basically entered the program, enabled the watchdog, and told it to bite every 15 milliseconds. Okay, so now let's go ahead and actually pat the dog. Let's see what this looks like. As you can see here, I have commented out the line WDT_reset in the forever while loop. This means that we will be patting the dog constantly in our loop. Now, let's take a look at what this looks like when we upload this to our MCU. And remember, we're using the include AVR up at the top, which is what allows us to use the watchdog. So as you can see here, it runs once, it blinked, and then it stopped. It did not blink again because it stays in that loop and it is constantly patting the dog, which means that the watchdog is not resetting our MCU, which means that we're not running through that setup function every 15 milliseconds. Alright, now let's see what happens if we remove that line, the WDT reset, which means that we're not patting the dog. So we're going back to the first scenario. We told the watchdog to bite every 15 milliseconds, but we're not patting it. As you can see, the MCU blinks repeatedly. Okay, so this is the basic idea of how the watchdog works. Okay, so here's that code for you to look at again. So we use the include up at the top so that we can include the AVR library, which lets us have access to the watchdog. Then in the setup function, which only runs once, we make the LED blink. Then in the loop, we actually enable the watchdog. So we're basically telling the watchdog, hey, bite back, and we're telling it to do so every 15 milliseconds. Now, he will only bite back so long as we don't pat him. Okay, so when this runs with the line commented out, the WDT reset, it means we're not patting the dog. So he's biting every 15 milliseconds. Okay, so how does this save power? How can we sleep the MCU and then have it wake up? Well, that's exactly what the watchdog is going to do when it bites. We're going to tell it to bite so that it wakes us up. So the watchdog can make us sleep, wake up, and this way we save power. Now, here's an example that you could find pretty much anywhere on the internet. And you can go through all the functions, but basically what we're doing here is we're including all the AVR libraries that we need. And the important number here is in line 6. It is an integer called number remaining, which is the number of times that we're going to want to sleep. And the reason is that the watchdog, as you can see on line 32, will only let you go up to 8 seconds before it bites you. So if we want to go more than 8 seconds, we need to loop that into a certain number of sleep cycles that can extend it for groups of 8 seconds at a time. And we'll see what that looks like in a minute. Let's look through some of the code very briefly here. Okay, so the first function is an internet interrupt service routine. And this is the one that actually has the WDT reset on it, or in it. The next function at line 15 is the configure WDT, and this is where we're going to enter all our parameters so that we can configure the different things that we want to about the watchdog. Remember, one of the most basic things you can configure is we can either tell the watchdog to wake us up, or we can tell the watchdog to reset us. And a lot of the things here in this function have to do with basically telling it to bite back for a certain amount of time. The next function, which is on line 35, is the sleep function, which is where we enter the number of cycles or the number of times that we're going to want the watchdog to bite every 8 seconds. So, for example, on line 21, which is the configure WDT function, you can see that we set the WDT CSR flag or register to 0B1000001, which, if you look down, corresponds to line 32 for 8 seconds. But we want to sleep for more than 8 seconds. So we use that in the sleep function to give it a number of times to count 8 seconds. So if we tell it to count 8 seconds twice, we're obviously doing it for 16 seconds, and so on. So let's go ahead and look at that sleep function. The sleep function takes in a number of cycles, and it sets it as the number remaining. So we can send the sleep command along with a number of cycles that it's going to have to count 8 seconds for. Then we use set sleep mode to power down mode, which is a very, very deep sleep and saves a lot of power. Then we manually turn off the ADC, which also helps in power reduction. And then we do the while loop for the number remaining, which is what you would expect for a loop function. Okay, now let's go ahead and look at the rest of the sleep function. In the end of the sleep function, we do power all enable. Because if you remember, we did power disable up above. When this function finishes, we want to make sure to enable everything back, or we're not going to have a fully awake MCU. Okay, the setup is pretty simple. We simply configure the we call the configure WDT function, and then we blink twice, actually 3 times there, yeah, twice, which is at the end of the setup function, so that we know that we have just finished setting up in case we reset or rebooted. Okay, and then in the loop, we immediately call the sleep function. So this is when we go to sleep. But this is also where execution will return right after this line. So this is where we're going to do our useful stuff. Now let's think about this. We want to set the MCU to sleep so that it saves power. Eventually, after the number of cycles it sleeps for is over, it's going to wake up. It's going to do whatever we tell it to do in the loop, which is our useful stuff. And then we want it to go back to sleep, because it's going to go back to the beginning of the loop function and run into the sleep line. So this is how we're going to make it save power, by calling the sleep function every certain number of cycles. Okay, so let's go ahead and load this thing up. And I have a multimeter here, and we're going to use it to measure current draw of our MCU. Let's go ahead and upload this, and here's my multimeter, and I am going to measure the current draw of the Uno to which I have uploaded this code. So let's go ahead and get this wired. So we need ground from the battery, and then there it is. Got that already set up, and I'm getting this cable ready here. We're going to actually, this cable is going to VIN, which is the VIN pin, and the other one I'm going to touch it to the battery. As you can see, it lights up, and at startup it draws about 0.4 and then drops to 0.3, does whatever it needs to do, and it's at 0.3 or 0.2, and there it is. And remember, right now it's basically sleeping, and it's going to wake up after about 40 seconds. So obviously we have to sit here and wait for 40 seconds to go by. I probably could have made this a little bit shorter, but okay, so it seems to be drawing 0.3 and 0.2 pretty solid. It's around 0.3. And there it is. It blinks, it draws 0.4, and then it drops back down to 0.3. Okay, so the reason why it's at 0.4, my multimeter is not that great, not this one. It's actually probably drawing around 280 right now, which is why it varies between 0.2 and 0.3. And then when it wakes up and does stuff, when it basically just blinks, it jumps up to 0.3 and maybe 0.380, which is around 0.4, which is why it rounds up. So it's sleeping, sleeping, sleeping. 40 seconds are up right about now, and then it's going to wake up. Current draw jumps up, it blinks, and then it goes back to sleep. All right, and if you have a better multimeter than I do, you can do a lot better job than I did here. All right, so that's basically how the watchdog works and how it can help us save power. So if we're back here at our model, what you are going to want to do is take the measurements at the warehouse, send the data via NRF to our office building, and then go back to sleep. In the meantime, office building is going to post to the internet. It doesn't matter. It's got a constant power source. It's plugged into a wall somewhere. No big deal. But if you're in the warehouse, you're probably going to be powered by some sort of battery source, probably solarly recharged. So you're going to want to save as much power as you can. So that means that you're going to wake up, do your important stuff, send the data over, and go back to sleep. And then maybe you can program that to happen every hour if you want measurements every hour, or half hour, or more. That depends on your needs. But basically, the important part here is that we're going to be able to set our MCU, the sender MCU in this case, the one at the warehouse, we're going to make it do its thing and then go to sleep to save power. And then the watchdog is going to wake it up 40 seconds later or 30 minutes later, whatever. It's going to do its thing again and it's going to go back to sleep. And that's the way we save power for autonomous remote projects such as this one. All right, so I hope that was as simple and as clear as possible. I try to take it really slow and I try not to put too much stuff into this video so that we can see it all come together in the next few ones. So if you have any questions, go ahead and drop them in the comment section. And I hope you enjoyed it. Don't forget to like, share, and subscribe. And I'll see you in the next video.